took this new quantum computer 5 minutes to solve a problem that would have taken our best supercomputer 10 septillion years to solve it.
But the idea is that they're pulling answers from different universes simultaneously. They don't even completely understand how this is working. But the amount of power in computing is incomprehensible, and it's probably the biggest breakthrough technologically in human history by a long stretch. And it's all happening without most people even being aware of what the implications are.
The world of quantum computing has taken a monumental leap forward, as a new quantum computer solved a problem in just 5 minutes that would have taken the best supercomputer 10 septillion years to complete. This achievement underscores the immense potential of quantum computing, a field that continues to evoke both excitement and uncertainty. Quantum computers promise to revolutionize fields ranging from encryption to artificial intelligence, but recent developments have pushed the boundaries even further. Google, a company already at the forefront of technological innovation, has made an extraordinary breakthrough involving its quantum chip. This discovery could fundamentally alter our understanding of the universe, with implications that are both thrilling and unsettling. Scientists are particularly alarmed by what Google's quantum chip may have uncovered, evidence pointing toward the existence of the multiverse. Once a concept relegated to the realms of science fiction, the multiverse may now be a tangible reality. This revelation has sent shockwaves through the scientific community, as it touches on deep, fundamental questions about the nature of reality and humanity's place within it. In this exploration, we'll delve into the details of Google's groundbreaking experiment, the multiverse theory, and why scientists are both excited and terrified by the implications of this discovery. To fully grasp the significance of Google's breakthrough, it's essential to understand why quantum computing is such a game changer. Classical computers, which have powered the digital revolution, rely on bits to process information. These bits exist in one of two states, 0 or 1. Quantum computers, however, operate on an entirely different principle. Instead of using regular bits, they use quantum bits, or qubits. Qubits are incredibly powerful because they can exist in a superposition of states, meaning they can simultaneously be in both the 0 and 1 states at the same time. This property vastly increases the computational power of quantum computers, enabling them to process information at speeds and efficiencies that classical computers simply cannot match. The possibilities of quantum computing seem endless, from simulating chemical reactions to decrypting complex codes. However, the technology is still in its infancy. Qubits are highly unstable and sensitive to their environment, making it challenging to maintain their superposition long enough to perform calculations. Despite these hurdles, recent advancements have brought us closer to practical applications. In 2019, Google made headlines by achieving quantum supremacy, a term that refers to a quantum computer performing a calculation that would be practically impossible for a classical computer to complete in a reasonable amount of time. Google's quantum chip, named Sycamore, successfully solved the complex problem in just 200 seconds, a task that would have taken even the most powerful supercomputers thousands of years. This milestone marked a monumental step in the development of quantum computing. However, Sycamore's capabilities extended beyond mere computational power. During experiments, researchers noticed something unexpected. The quantum system began behaving in ways that defied expectations. The data suggested that the results were not random or inconclusive, but instead hinted at interactions with something beyond our three-dimensional reality. This anomaly raised the possibility that quantum systems might be interacting with other universes, providing evidence for the multiverse theory. The multiverse theory proposes that our universe is not the only one in existence. Instead, there may be countless other universes, each with its own set of physical laws, constants, and realities. Some versions of the theory suggest that these universes exist side by side, undetectable by our instruments, while others propose radically different universes, possibly containing alternate versions of ourselves or entirely different forms of life. There are several types of multiverse theories, including the bubble multiverse, which posits that our universe is just one bubble in a larger multiverse, and the many worlds interpretation, which suggests that every quantum event creates multiple universes, each representing a different outcome. String theory also offers a multiverse model, proposing extra dimensions that could give rise to multiple universes with unique properties. While these theories have long been speculative, Google's experiment may have provided the first empirical evidence supporting their existence. During Google's experiments with the Sycamore chip, the quantum computer was tasked with solving a complex problem related to optimizing quantum states. As the calculations progressed, the chip began to show interference patterns that shouldn't have appeared based on expected results. These patterns suggested that the quantum states were being influenced by factors outside the realm of normal quantum mechanics. Some researchers believe this could indicate interactions with other universes within the multiverse. In quantum mechanics, particles can exist in multiple states simultaneously, but collapse into a single state when observed. However, the data from Google's quantum chip showed that these states were not just collapsing into one reality. They were interacting with multiple potential realities. This implies that the quantum system might be tapping into something far beyond our universe, raising the possibility that our understanding of reality is far more complex than we ever imagined. The scientific community's reaction to this discovery has been a mix of alarm and excitement. On one hand, the data could simply be an anomaly resulting from imperfections in the quantum system or computational errors. Quantum systems are notoriously finicky, and even small measurement errors can lead to surprising results. On the other hand, if the data is correct, it could signal the existence of something that fundamentally changes our understanding of reality. If quantum systems are indeed interacting with a multiverse, it would require a complete overhaul of much of modern physics. The implications are immense, potentially opening the door to a new realm of physics where the boundaries between universes are not as solid as we once believed. However, this discovery also raises serious concerns. If quantum systems are interacting with other universes, could this destabilize our own universe? Could the fabric of reality be at risk? These are questions that scientists must address urgently. The ethical implications of this discovery are profound. If the existence of the multiverse is proven, it will raise numerous ethical questions. Should we continue experimenting with quantum systems if they have the potential to interact with parallel realities? What if these interactions have unforeseen consequences? Could quantum computers inadvertently open rifts between universes, unleashing forces we are not equipped to handle? The ethical dilemmas surrounding this discovery cannot be ignored. Scientists must carefully consider whether the pursuit of quantum supremacy is worth the potential risks. For now, the excitement of discovery is tempered by deep uncertainty about what could come next. From a technological standpoint, Google's quantum chip experiment opens a new frontier in our understanding of quantum mechanics and the underlying nature of reality. If the data from Sycamore is accurate, this marks the beginning of an entirely new chapter in physics. For decades, physicists have wrestled with theories like string theory, the multiverse, and quantum entanglement, often finding themselves trapped in complex equations and speculative models. Google's discovery could be the key that unlocks many of these theories, bringing them into the realm of empirical science. The potential applications are staggering, from revolutionizing cryptography and material science to advancing artificial intelligence. However, the most profound implications lie in the possibility that this breakthrough could provide insight into even deeper, more fundamental laws of physics. The existence of the multiverse could explain some of the most perplexing phenomena in science, such as the fine-tuning of the universe for life. If our universe is just one of many, the fine-tuning we observe may simply be a result of our universe being in the right place among many. To truly understand why this discovery has sent shockwave through the scientific community, it's important to delve into the physics behind it. Quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales, is closely tied to the multiverse hypothesis. At these tiny scales, particles don't follow the predictable patterns of classical physics. Instead, they can exist in multiple states at once, a phenomenon known as superposition. Quantum entanglement, another mind-bending aspect of quantum mechanics, occurs when two particles become linked in such a way that their properties are directly related, regardless of the distance between them. This spooky action at a distance, as Einstein called it, defies classical ideas of space and time. Google's Sycamore chip's unexpected behavior suggests that quantum entanglement might not be confined to particles within our universe but could extend to other universes in the multiverse. This would allow for the type of interference and unusual quantum behavior that Google's chip detected, potentially indicating interactions with parallel universes. The concept of the multiverse goes beyond theoretical curiosity. It touches on the fundamental nature of existence. If there are indeed multiple universes, each with its own distinct properties, our universe may not be the unique, singular reality we once thought it was. Instead, it could be just one of many, each with its own version of physical laws and constants. Some versions of the multiverse theory suggest that each universe may have different physical constants, meaning that the fundamental forces of nature, gravity, electromagnetism, and the weak and strong nuclear forces could differ from one universe to another. In some universes, life may never have arisen, while in others, the conditions may be completely hostile to life as we know it. The more fantastical versions of the multiverse theory propose the existence of parallel universes where different versions of ourselves exist, leading to alternate versions of our lives based on different choices. While this may sound like science fiction, Google's quantum chip's findings raise the tantalizing possibility that these alternate realities could be real. Despite the excitement, the discovery of the multiverse through Google's quantum chip also raises significant concerns. If quantum systems are indeed interacting with parallel universes, what are the consequences? Could there be unintended effects on our universe? One concern is that manipulating quantum systems at the level of the multiverse might inadvertently create rifts or instabilities between universes, potentially leading to catastrophic outcomes. The problem is that quantum mechanics is still not fully understood. While we've made incredible strides in harnessing quantum principles for technologies like quantum computing, we have yet to fully comprehend all the implications of quantum entanglement, superposition, and the potential for multiverse interactions. Physicists like Stephen Hawking have warned that quantum technology should be approached with extreme caution, as we are dealing with forces that could be far beyond our current understanding and control. The ethical dilemmas surrounding this discovery are profound. Who controls this technology? Should it be regulated? And if so, by whom? What happens if a government or corporation gains control over quantum computing technology and uses it for purposes we can't even imagine? One of the key ethical questions is the responsibility of scientists and researchers in this rapidly advancing field. If the quantum systems we're developing are capable of interacting with other universes, should we proceed with these experiments at all? Can we be sure that we fully understand the consequences of such interactions? Or is there a risk that we're playing with fire, unaware of the potential dangers? Moreover, the discovery of the multiverse could challenge some of our deepest philosophical and existential questions. If multiple universes exist, what does that mean for the concept of free will? If alternate versions of ourselves exist in other universes, does that make our choices any less significant? These questions could have far-reaching consequences for how we view ourselves, our decisions, and our place in the cosmos. Despite the potential risks and uncertainties, Google's quantum chip discovery has undeniably opened the door to a new era of scientific exploration. It's a momentous breakthrough that could provide answers to some of the biggest questions humanity has ever asked. Are we alone in the universe? Is our universe unique? Or is it just one of many? What is the true nature of reality? The fact that quantum computing may be able to detect and interact with the multiverse challenges everything we thought we knew about space, time, and the fundamental laws of physics. It's an exciting, terrifying, and awe-inspiring prospect, marking the beginning of a new chapter in science where the boundaries of what we know are pushed further than ever before. As the world watches in awe, the next steps will be crucial. Researchers will need to continue examining the data, refining their methods, and ensuring that quantum computing can be used safely and responsibly. But no matter what happens next, it's clear that Google's quantum breakthrough has fundamentally altered the way we look at the universe and may have just opened the door to a whole new reality.